In terms of like that part, obviously we looked at how to tell if something's polynomial or not. But we started with direct substitution, where we just take it and plug the number directly in. But the new thing that I introduced was synthetic substitution, where we need to make sure that our terms, that we're in standard form. If we have any missing terms, we've got to put a 0, which I don't know if any of these problems necessarily have that. They might, but we'll see. But it definitely will come later when we're doing stuff with synthetic. But we take the number that x is equal to and we put it in the box, write all the numbers down, and then multiply and add. And then the answer that we get over here is our final answer, and you can verify it by direct substitution. So if you are looking for a method to check your work, that's the way you can do it. So let's look at 18. H of x is equal to negative 8x cubed plus 14x minus 35, and x is equal to 4. Alright, so is this in standard form? Are the terms in descending order? Yes. Yes, okay. Am I missing any terms? Which one? Yep, the x squared term is missing. So sometimes what I'm doing, especially when I'm getting like used to it, is I'll put that there just so that when I go to copy my numbers down, I don't forget to put that 0 in. You do not have to do this, but it just can help you a little bit while you're getting used to them. So 4 goes in the box. Then copying each of the numbers in order with their sign. So negative 8, 0, 14, and negative 35. So I start out by bringing down the negative 8. Multiply by 4, so that's negative 32. Plus 0 is negative 32. Times 4 is 128, negative 128. Yeah. Add 14, so that's going to be negative 114. Times 4, oh goodness, 16, 5, negative 456, I think. And then combine those, so 491, and it's negative 491. So that would be your final answer there, negative 491. Uh, 20 g of x equals 6x to the 5th plus 10x cubed minus 27, and x is equal to negative 3. So, am I in descending order or standard form, and am I missing any terms? Yes and yes. Okay, they're descending, so 5, 3, 0. So I'm missing x to the 4th, so 0x to the 4th, and I'm missing x squared. I'm also missing x. So I have 3 missing terms, actually. So, negative 3 is going in the box. Then in order, 6, 0, 10, 0, 0, and negative 27. Bring down the 6. Times negative 3 is negative 18. Plus 0 is negative 18. Times negative 3 is 54. Add 10 is 64. Times negative 3 is negative 192. Plus 0 is negative 192. Times negative 3 and 576. Plus 0 is 576. Times negative 3. Gracious. 18, and negative 1728, I think. And then minus 27. To add those together is 15. So negative 1755 would be the answer to that one. And obviously you'll have your calculator, so you don't necessarily have to, I mean, I'm multiplying them in my head and I know you can, but if you just want to speed up the process, you can. Do we need to see another one of these, or are we okay on this one? Feel okay? Okay. All right, then the last thing in this section that we're going to look at, and this is, I mean, we do a little bit with it in pre-cal, so like every year we progressively do a little bit more all the way out until you get to calculus, where we do a ton with it. But it's what's called in behavior. Okay, so that's what's happening as the graph gets really, really big in either direction. Okay, so we look at something like 28. So the instructions for this, I guess I should say, describe the in behavior of the graph of the polynomial function by completing these statements. So it says f of x goes to blank as x goes to negative infinity, and then it does the same thing, but as x goes to positive infinity. So the way that we're going to look at this is with limits, okay, because that's the way that you're going to see it after this class, so it's the same thing. So 28, f of x is equal to 10x to the fourth. So I'm going to be answering the question, the limit as x goes to infinity of 10x to the fourth. So basically, if I plug in a really, really big number, okay, so I like to think of it as like 500 because that's something I can comprehend. I mean, you can't really comprehend infinity. If I plugged in a positive 500 to this, okay, you don't need to give me the exact number that it's equal to, but what is happening to this number? Is it getting really big or really small? Really big. So this is equal to infinity. Okay? Because if I chose, instead of 500, if I chose 500,000, right, that number is going to keep getting bigger. And ultimately, as x gets as big as it possibly can, which is infinity, that's just going to go to infinity. Okay? The limit then as x approaches negative infinity, so that's answering the other part of the question, of 10x to the fourth. So if I plug in something like negative 500 for x, where's this one going? Is that number getting really big or really small? Are you sure? Yep, so the negative is being raised to the fourth, so if it's raised to an even power, right, then that means that the sign, it's always going to be positive, because negative times negative is positive, and then negative times negative is positive, so it's going to end up being positive, so this is also going to positive infinity. So what you're going to notice about these is that we're looking at basically the exponent on the variable, okay, and also the fact that the number in front is positive. That's also making a difference. So then, like 30, f of x equals negative 2x cubed plus 7x minus 4. So with this one, I'm going to do the limit as x approaches infinity. Instead of writing out, since this function was short, I just wrote it, but you can also just write of f of x because it's referencing what's up here. Now, what some people tend to do is they get thinking, I need to plug in stuff for every variable and analyze it for the whole thing. But if I take let's just hypothetically say a really big number, and I add more to it, what happens? It just gets bigger, right? So that's not really changing anything. So when I'm looking at in behavior, I only care about the highest powered term. Okay, so I'm just going to ignore this. I can erase it and just forget that it's even there, because it's not going to change it enough to make a difference. So if I plug in something like positive 500 to negative 2x cubed, what's going to happen? Yep, it's going to be negative and a really big number, so negative infinity. Right, because I plugged in a positive times the negative, so it's negative but still a really big number. Now when I do the limit as x approaches negative infinity of f of x, so if I take negative 500 and I cube it, and then I multiply it by negative 2, what's happening? Bigger, and what's the sign on it? Positive. Yeah, so it's going to be positive infinity. Okay, so that's why I'm saying you've got to watch the signs specifically. Your answer will always either be infinity or negative infinity. Okay? If it's an odd exponent, they should be opposite. One should be positive, one should be negative. If it's an even exponent, they should both be the same. Either both positive or both negative. Okay? Let's look at one more. 32. F of x equals 3x to the 10th minus 16x. So when I do this problem, what am I looking at, or what's the only thing I care about?
3x to 10.
Yep, all I care about is that right there. So the limit as x approaches infinity. Also, just like random, because people ask me this all the time, is there a reason that this L is cursive? No, it's just because if you do a regular one, it kind of looks like an I or a 1, so I just do it cursive, but you don't have to. So of f of x, so if I plug in a really big number here, what happens? And the sign is positive. Now, is this even or odd? So these both should be what? So they both should be the same, but we always check just to make sure, because you never know if you use something wrong. So if I plug in negative 500, raise it to the 10th, multiply it by 3, what do I get? Positive infinity. Any questions on that? And this is obviously the very basics of limits and what happens within behavior. There's so much more that we can do with it. They won't, in behavior won't always go to infinity and negative infinity, but for the sake of this book and what we're doing with it as the very intro, it will. Okay? The only other option really is for it to go to 0 for in behavior. But we don't have any like that in this book. So, problems 5, 7, 9, 11, hold on. Oh yeah, those are all different. 15, 19, and then 29 and 31.